Hello, today in this video lecture we will see numerical 2 on shear force and bending moment diagram. So first, by our judgment, or in our previous video lectures we had seen how shear forces and bending moment diagram comes. So by that judgment we will directly roughly draw shear force and bending moment diagram, and after that we will calculate values of that. So, see, 100 kilonewton, 600 kilonewton, 175 kilonewton loads acts on this 7-meter simply supported beam. So, these loads are downward loads, and every action there is equal and opposite reaction. So, these reactions, red color reactions, comes upward. So, by that judgment, we will consider here shear force is upward. This red color at point A, see at point A, this red color is upward, so reaction is upward, that means shear is also upward. And at point A to B there is no load, this 2-meter span there is no load, so when there is no load then shear force is horizontal line. So like this, at point D 100 kilonewton point load acts. Due to this 100 kilonewton downward point load, this shear force drops suddenly, and it drops like this. And at point B to C, there is also no load. That means there is also horizontal line. And at point C also suddenly drops 600 Newton load. So here 600 Newton is also. And at point C to D also they were at that 1.5 meter span no load. That means horizontal line. No load, that means shear is horizontal line. At point D 175 kilonewton, that means here also drops. Why it drops? Because this is downward arrow. Now at point D to E also no load, that means horizontal line. And at point E this reaction is upward, that means here this is upward. So at point A, B, C, D, E, this is negative shear, this is positive shear. So where shear force is maximum? As per your judgment, where is shear force maximum? See loads first. This is 600 Newton. From E it is 3 meter, and from A it is 4 meter. So as per my judgment, here maximum shear force comes because load is maximum near to this point E. We will see wrong or right, but first judge it. Now bending moment. At point A and E, bending moment is 0 because this is simply supported. Simply supported, that means at point A or E, either it is hinge support or roller support, and for hinge support and roller support, movement is 0. At point B, C, between A B there is no load. When there is no load, that means there is bending moment is inclined line. Before that, see deflection. Deflection of that beam is like this. Deflection like this, that means this is sagging bending moment, positive bending moment. So let's deflection downward, that means this is sagging bending moment. So sagging bending moment, that means positive bending moment. At point AB there is no load, that means here this is inclined line. So at point B like this, at point C this is clockwise movement, anti-clockwise movement, this is like this. At point C, at point D it is like this, and at point E it is 0. that means this is positive. So now calculate values for that SFD and BMD. This is SFD, this is BMD, and here maximum as per my judgment, because C deflection is maximum at point C, and at mid there is C. As per my judgment, here it is maximum, so we redraw it diagram like this, because C shear is 0 here. When shear is 0, then their bending moment is maximum. Preliminary we only judge it. Now after that we will calculate exact values. Here like this, like this, like this, and this. This is positive, and here at point B it is maximum. Now calculate whether our judgment is correct or not. So first calculate reactions. Which reactions? AY and EY. For that we will consider summation of forces in y direction is equal to 0, equilibrium. So 100, 600, 175, 100 plus 600, vertical direction force we consider positive and downward direction negative. Vertical direction consider positive. That means these reactions we consider positive for calculation. And if that reactions comes positive, that means this assumption upward is correct, and if this reaction comes negative, that means this upward direction arrow is not correct. This is downward direction when it is negative. So let's calculate it. AY and EY, our main objective right now. So AY plus EY upward, that's why this is positive, minus 100 minus 600 minus 175 equal to 0. So AY plus EY is equal to 600 plus 100 plus 175, that means it is 875. And what is unit? See, load is in Newton, that means it is in Newton. Now our objective is not AY plus EY, our objective is AY and EY. So for that we need to calculate either AY or EY. So for that I consider this A point, and at A point I calculate moment. So this EY we will find by moment equal to 0 equation, this EY. So now summation of moment at A. Why I take this summation of moment at A? Because my objective is to find this EY, and this EY I put in this equation 1, then I get AY. So, and here I consider clockwise as positive and anti-clockwise as negative. So here for that point A, this EY is anti-clockwise, that means anti-clockwise negative, that means minus EY into 2 plus 2, 4, 5, 5.5, 6 and 7, that means this is 7 meter, 2, 2, 4, 5, 6, 7, yes, 7 minus this 100, 600, 175 are clockwise to this point A. So positive value comes clockwise, that means positive 175 into this is 2 plus 1.5 4 5.5 plus 600 into 4 and plus 100 into 2 and equal to 0. So this EY comes minus EY into 7 plus 175 into 5.5 plus 600 into 4 plus 100 into 2 equal to 0. So it is 508.93 kilonewton. See, this EY is 508.93 kilonewton. Put this EY here. That means this AY is equal to 875 minus 508.93. It is 366.07 Newton. See, here it is mistake. Here it is Newton, not kilonewton. So, how you confirm that our AY and EY reactions are correct? So for that, see, this AY plus EY is equal to 875 Newton. This 100, 600, 175 Newton load acts on this beam and reactions AY, EY. So every action there is equal and opposite reaction. That means equal and opposite. So this AY is 366.07 and EY is 508.93. It is 875 Newton. And all load summation is also 875 Newton. 100 plus 600 plus 175. 875 Newton. So our reactions are correct. So we don't need these calculations now. Our objective is finalize or achieve. Next is we will calculate shear force values. For shear force calculation we need these reactions. So I write this AY here. AY is equal to 366.07 Newton and EY is equal to 508.93 Newton. Now second step is to calculate shear force. So shear force at A is equal to this reaction, AY reaction, 366.07 Newton. So this value is 366.07. Now shear force at B and just left to that B is also 366.07 Newton because there is no load between AB. Now shear force at B just right to that B is 366.07 minus 100. See, this 100 is downward. That means 366.07 minus 100, it is 266.07 Newton. Means here, so see, our assumed shear force is like this, because this 266 is positive. That means 366.07 minus 100, it is not negative, it is positive, like this. So for that I mark it by color, this color, it by this yellow color. This is correct SFD. Yellow color SFD is correct SFD, because I just assume firstly. So this is through 66.04, and shear force at C just left is also 266.07, because no load in between, that's why the shear force not change. So shear force at C just right is this 600 minus 266.07 minus 600, 266.07 minus 600, that means it is minus 333.93 Newton. So like this, like this. So erase it. So this is 266.07 and this is 333.93. Now shear force at point D just left is also minus 333.93, because no change in load, and shear force at D just right is minus 333.93 minus 175, because this 175 Newton load acts downward, so it is minus 508.93. And shear force at E is vertical, that means it is positive 508.93, because this is reaction at E. So preliminary, my diagram is slightly wrong, but see, this my maximum is correct, because this is 508.93. And how I assume this as a maximum, because see, this is loads are maximum at point E. Towards point E loads are maximum, that's why shear is maximum at point E. Now our next step is to calculate bending moment diagram values. We will see my assumed bending moment diagram shape is right or wrong. So our next step is to calculate bending moment diagram. values. So first, calculate bending moment at A. It is 0 because this is simply supported beam. Here this point is E and this point is D and E. So, and at point E also bending moment is 0. So now calculate bending moment at point B. Bending moment is nothing but the load into perpendicular distance. So this load is A by 366.07 into 2. 366.07 into 2 is 732.14. Load is in Newton and distance is in meter, so unit is Newton meter. Next is bending moment at point C. C, clockwise is positive, anti-clockwise is negative. So this 366.07 is clockwise, and at point C distance is 4 meter, minus because this 100 km is anti-clockwise, into distance between 100 km and point C is 2 meter. So minus 100 into 2 is C 366.07 into 4 minus 100 into 2 is 1264.28 Newton meter. So my SFD shape is wrong. That's why my BMD shape is also wrong. My BMD shape is like this. Here it is minimum and here it is maximum. So our correct BMD is like this. Now calculate bending moment at point D. At point D, I calculate bending moment from right side. And when we calculate bending moment from right side, bending moment value we take negative. If value comes positive, then take negative. If value comes negative, then take positive. So this EY is anti-clockwise. Sign convention is similar. Clockwise positive, anti-clockwise negative. EY is anti-clockwise, so 508.93 negative 508.93 into distance is 1.5. So 763.395. Value is at point D from right. This EY is 508.93 anti-clockwise. That is minus 508.93 into 1.5. That means minus 763.395. And this minus value take positive because we considered from right side. So positive 763.395 Newton meter. And at point E it is 0. So values are here 0 Newton meter, here also 0 Newton meter, here at point B it is 732.14 Newton meter, at point C it is maximum because here is 0 here. So at point C 1264.28 Newton meter, and at point D it is 763.395 Newton meter. So our values are correct and SFD BMD shape is also correct. See one term dV by dx is equal to minus x, and dm by dx is equal to minus b, and dv by dx is equal to, this is plus x. D square m by dx square is equal to minus x dv by. So this x is this loading, x constant, dv by dx constant, and v is linear. That's why this is horizontal line. See this shear v constant, dm by dx constant, v linear, dm by dx linear, but this m is inclined. So that's why I write these equations. X constant, that means in between AB there is no load. So dV by dx ratio is also no load, but this V is 1 ratio higher, V is linear. dm by dx is equal to minus V, that means minus V is linear, that means dm by dx is also linear, but this m is 1 ratio higher, 1 power higher, that means this is inclined. D square m by dx square minus x is also similar. This x is constant, d square m by dx square is also constant, but this m is 2 power higher, m is inclined. So that's it. Thank you very much.